Let's look at final exam question number 7 in Physics Demystified, 2nd edition. Please see page 513 if you have the printed book, and figure exam-1 pertains to this particular situation, reproduced here with color embellishments. This figure illustrates something. What is it? What can we measure with something like this? This is a mass, an object with a certain amount of heft or mass. Say, I don't know, a ball bearing or something like that. This device has 2 rigid plates, and we compress them against this object to hold it in place. These springs, which are identical, are attached to a rigid frame around the outside. The diagram actually is a little bit clearer than this, although certainly not as colorful. What can we do with this thing? Well, this particular device is good for measuring the mass of an object like this mass, in a weightless environment, and that is choice E. In a weightless environment, you can't use an ordinary scale to measure mass because there's no force of gravitation pulling on that mass. What you need to do is figure out a way to measure the inertia that this mass has. If you try to push on it, it's going to resist you. You have to find a way to measure that, and what you can do with an object like this, put that mass in there and then push it over to one side. These springs are identical and it'll start oscillating. The speed of that oscillation is going to depend on how much tension there is in these springs, how strong they are, how springy they are. But once you know that, and once that's a fixed and constant quantity, then the speed of oscillation will vary with the mass. The more mass, the slower the oscillation will be. Of course, you have to take into account the mass of the whole system, the plates and the springs themselves. But you can do experiments and calculate that and create a graph or a curve or a function which will allow you then, in a weightless environment, say on a spaceship orbiting the Earth or traveling through the galaxy, if you need to measure the mass of a ball bearing for some reason, or your own mass for that matter, see if you've gained or lost any weight, you can do it. Gained or lost any mass, I should say. Weight depends on how strong the gravitational field is, but mass does not. Mass is simply a measure or an expression of the amount of stuff, and that's an absolute. It doesn't depend on gravity. So this device, this is one relatively primitive way to measure mass in a weightless environment. That is choice E.